Hi, this is Mr. Erlin wanting to go over factoring a little bit for quadratics. This is a refresher video for those in geometry who may have forgotten some of the components of algebra. To begin with, let's talk about what some people call foiling, which is a form of distributive property. If I have a binomial term and I multiply it by another binomial term, I'm obligated to distribute this x across both of these terms, x and the -3. And I'm going to distribute the 2 across both of these terms. Oftentimes, this is described as foiling because you multiply the first terms, and then you multiply the outer terms, and then you multiply the inner terms, and then you multiply the last terms, which is why this is called foiling. So for example, if I were to multiply this out, I'd get x times x is x squared. X times -3 is -3x. 2 times x is positive 2x. And then positive 2 times -3 is a -6. And whenever we do this, we discover that there is a term with an exponent of 2, and there's a constant, and then there's 2 terms that have x with an exponent of 1. These 2 terms will combine, and we're going to get x squared minus x, or 1x, minus 6. This form is called a quadratic expression, and the reason it's called quadratic is because the variable x shows up with an exponent of 2. There's nothing in the denominator like over x or over x or over x. That makes this a polynomial. And within the polynomial world, this is a trinomial because it's 3 terms, whereas this is a binomial because it's 2 terms. But the important part here is that it's quadratic in nature. When we're solving quadratics, there's 4 scenarios, really. The first is when we've got a simple x squared equals a number, in which case we ask ourselves, just as we do with most solving, can I just square root both sides? In other words, what's being done to x? Can I undo it? In this case, x is being squared, so I'm going to square root it to undo that side. And I'm allowed to do that operation to the left side as long as I also do it to the right side. In this case, the square root of x squared becomes x, and the square root of 16 is a positive or a -4. That's a step that a lot of people forget. When we introduce the square root symbol, we have to recognize that there are both a positive and a negative possible responses. What does this mean that we end up with 2 responses? Why are there 2 answers? Well, the reason is because obviously, if I put in a positive 4 and I square it, I get 16. And if I put in a -4 and I square it, a negative times a negative is also positive, I get 16. But the bigger reason is because if I subtract 16 from both sides, I get x squared minus 16 equals, well, let's say instead of 0, let's say that I were to treat this as a function. In other words, a relation between x and y where every x yields exactly 1 y value. And if I were to graph this function using transformations, we might remember that I'm ending up with a parabola whose parent function is centered on the origin over 1 up 1, over 2 up 4, over 3 up 9. But because this is a transformation of down 16, I end up with going down here 16 points, and then I end up with a parabola that goes up, going in both directions. And what this describes is what happens when y equals 0. And when y equals 0, that's along the x-axis. And we're going to end up with 2 x-intercepts. That's why we have a positive 4 and a -4 as a solution here. But I digress. The first way of solving is when it's just x squared and a constant. You can put the constant on the other side and solve it that way. Secondly, in the event that you have just, for example, x squared plus 5x equals 0, what you can do is factor both parts. You can say, okay, this is x times x, and this is 5 times x. And we're asking, what's common to both of these? Well, they each have an x in them. So if I factor that x out, which is sort of like division, but really it's like unmultiplying. I'm like pulling out something multiplied here, and I say, okay, then x times what would give me x squared? X plus, and then x times what would give me 5x? That'd be 5. And now we reach a really important, a critical part of the quadratic solving process, which is the idea of the zero product property. What the zero product property says is that anytime you have two expressions multiplying together to make 0, one of them has to be 0. Like let's say that x is 10 here. I know that this is 10 times 10 plus 5. That's not going to equal 0. If I put in like a -3 here, -3, this makes a +2, negative times a positive is going to be a negative. It's not going to be 0. The only way I can multiply two expressions to be 0 is if one of them is 0. So I'd separate the two factors, say either x equals 0 or x plus 5 equals 0. If x equals 0, then x equals 0. If x plus 5 equals 0, then I can subtract 5 from both sides of the equation, and I get x is equal to -5. These are my two answers for this problem. So when I have a single number, a single x squared and a constant, I can just solve by square roots. When I have an x squared and a constant and a single x term, x to the first, but no constant, I can do it this way. But the hardest ones come about when I have all three. When I have something like x squared plus 5x plus 6. And let's go that this is equal to 0 already. I have a term with an x squared, I have a term with an x, and I have a constant. So now what I need to do is I need to turn this into what it would have been before I FOILed. Because if I can do that, then I know that this and this multiplying together make 0. Either this one equals 0 or this one equals 0, and I can get to a solution. In order to get there, there's a couple of techniques. I know that the first two things are going to produce x squared. So sure, those are x and x. But these two terms have to multiply together to make 6. And the challenge is, it could be 3 and 2, it could be 6 and 1, it could be 12 and 1/2, it could be 24 and 1/4, it could be 30 and 1/5. There's too many options that multiply to make 6. And I need to recognize that my inner and my last terms are going to come together, adding together as middle terms to make plus 5x. So we use this thing called a diamond, where we take this term and put it up here, plus 6. And then we take this term and we put it down there, plus 5. And now we're looking for two numbers that multiply together to make 6, while at the same time add together to make 5. So I'm going to take all the factors of 6. It could be 6 times 1. It could be -6 times -1. It could be -3 times -2. It could be +3 times +2. And yes, it could be 12 times 1/2 and 24 times 1/4. But I know that those things would never add up to an integer. I would end up with fractional sums. That's not what I'm looking for, so I'm going to ignore those. And now I'm going to look for, among all these, which ones add up to 5. 6 plus 1 is 7, -7. -3 and -2 is -5. +3 and +2, that makes 5. So I'm going to add those in here. So in concept, remember when we did the foiling before, we took it from the FOIL position and we ended up with a 4-term expression, right? Because we ended up with the inner part and the outer part both being x to the firsts. And then we were able to combine to go here. Well, now we're going backwards. So we need to take this middle term and break it up into 2 parts. And we want those 2 parts to be a specific 2. Sure, I could call this plus 4x and plus 1x, or plus 7x and minus 2x, but I'm going to choose to use these. That's what the diamond's for, is it tells me how to break this thing up. So I'm going to break this up into plus 3x and plus 2x, because that's what I got here. Now I'm going to factor by grouping. I'm going to again look at this and say this is x times x, and this is 3 times x. What's common to both of these? Well, there's an x in each of them, so I'll pull that x out. What's left is x plus 3. Now I'm going to do the same here. What I've got is 2 times x, 2 times 3. What's common to both of these is a 2. So I pull the 2 out. Once I pull the 2 out, what I'm left with is x plus 3. And if I did this correctly, what I find is that this central binomial term and this binomial term are the same. And now this is always a brain buster for people. But just as here, I found something that was multiplied times the first term, and at the same time multiplied by the second term, and I pulled that out front. I'm going to do the same thing here. This term and this term each have x plus 3 as a factor. So I'm going to pull that out. I'm going to put x plus 3. I'm going to pull that out, and what's left then is x plus 2. And that's what I was looking for here. So I was trying to get it into this format, which I've done. I've now got x plus 3 and x plus 2 equals 0. Because this is a quadratic, I needed to get it to set equal to 0 so that I can apply the zero product property. I now know that either x plus 3 is equal to 0 or x plus 2 is equal to 0. If x plus 3 is 0, I can subtract 3 from both sides using the subtraction property of equality and get x equals negative 3. For x plus 2, I can subtract 2 from both sides and I get x equals negative 2. These are my two solutions. If I were to plug these back in, 9 minus 15 plus 6, I would get 0. And if I put in negative 2 squared is 4 minus 10 plus 6, that would also give me 0. So these are the two solutions, or the roots or the zeros to this function. We're going to see that we have more challenging problems sometimes. What if we had, for instance, x squared minus 3x equals 40. Okay. So first step is recognizing that I can't start it with this setup. The first thing I need to do is get one side equal to 0. So I'm going to subtract 40 from both sides. That's going to give me x squared minus 3x minus 40 equals 0. Now I'm set up. This is the setup I like. It's set equal to 0, so I'm ready to apply my diamond process. Ends term here, negative 40. Middle term here, negative 3. It's going to multiply times 40 and add to 3. Okay, so I'll look at my factors of 40. I've got 40 and 1. And of course now, my product is a negative number. So that means I could either have negative 40 times positive 1 or positive 40 times negative 1. I could have negative 20 times positive 2. I could have positive 20 times negative 2. 3, 4. I could have negative 10 times 4. I could have positive 10 times negative 4. 5. I could have negative 8 times 5, or 8 times negative 5. 6. And that's it. Those are all my integer factors. Now, among those, I'm looking for which one has a difference of 3. Because one is positive and one is negative all the way down, I know that when I combine these terms, it'll be 40 minus 1, 39. It'll be 20 minus 2 is 18. It's the difference between the terms. My difference here is quite small. It's only 3. So I'm looking down here where these two numbers are closer. Since this is a negative number, I expect my bigger value to be negative so that it overwhelms the positive component and gives me an answer that is a negative value. In this case, I can see that negative 8 and 5 have a difference of negative 3. So I'm going to put those in as my solutions. And again, At this point, I'm now going to rewrite this original expression. X squared and minus 40 and 0 are all the same, but I'm going to take this negative 3x and I'm going to break it up strategically into negative 8x plus 5x. Now I'm going to say, what's common to these first two terms? Well, there's an x, so I'll pull that out. What I'm left with is x minus 8. What's common to these two terms? Well, this is 5 times x, and I can treat this as 5 times 8. So pull out a 5. X. When I pull out the 5, I'm left with x minus 8. And again, this is that step that is a little bit counterintuitive. I'm treating this as a term, and I'm treating this as a term. And I'm looking for what factors both of these terms have. Looks like x minus 8 is in both of them, so I'll pull that out. When I pull that out and that out, what I'm left with is x plus 5. And again, now I can apply the zero products property. If these two terms are multiplied times 0, then either this one equals 0 or this one equals 0. If this equals 0, I add 8 to both sides, and I get x equals 8. And if this one equals 0, I subtract 5 from both sides, I get x equals 5. Those are my two solutions. And if I were to put in 8 up here, I'd get 64 minus 24 equals 40. That works. If I put in negative 5, I'd get positive 25 plus 15 makes 40. That also works. Now, things get a little bit harder when I've got a lead coefficient. So let's say, for example, I've got 2x squared. Think about what I want to do with this here. Okay, so let's say that we're given this thing equals 0. Step 1 is get it set equal to 0. I've already got that. Step 2 is to do the diamond. But remember that the diamond is intended to find out what goes in the middle, assuming this was a 1 coefficient. It's not now, it's a 2. So there's a little adjustment here. I actually have to take the product of these two to put them up here. When I had this problem, I was doing the same thing. I put a 6 over here. Really, that was a product of this 6 and the lead coefficient of 1. 6 times 1 is 6. And when I did it here, I moved this over and I said negative 40 goes up here because that's a product of 1 and negative 40. So it works fine. It's just we didn't really see what was going on. Now we're going to do 2 times negative 12, so negative 24. And on the bottom, we've got a negative 5. I'm looking to multiply times to make negative 24 and add to make negative 5. So what are my factors of negative 24? Well, negative 24 and 1 and 24 and negative 1. Negative 12 and 2 and 12 and negative 2. 2, 3. Negative 8 and 3. Positive 8 and negative 3. 4. Negative 6 and 4. Positive 6 and negative 4. 6. Okay, we're back. I'm looking for a difference of negative 5. Again, because one's positive, one negative, I'm subtracting 24 minus 1 is 23, 10, 5. Okay, so it's in this realm. It's in the 5s. I want a negative 5, so I'm going to choose the negative 8 and the positive 3. And I'm just going to rewrite this expression. 2x squared minus 12 equals 0. Instead of a negative 5x, I'm going to break it up like this. Negative 8x plus 3x. Now I'm going to take my lead coefficients here. This is 2, and I'm going to factor the remainder, x. And this is 2 times x. Oops, one more 2. What do I have in common? I have 2x here, and I have 2x here. So I'll pull that out. What am I left with? X minus 2 times 2 is 4. Now let's do it over here. 3 times x minus 3 times 2 times 2. I only see a 3 in common, so I'll pull that out. What am I left with? X minus 2 times 2 is 4. And again, I'm looking for now this term versus this term. What's common? Well, the x minus 4 is common. So I pull that out. What am I left with? 2x plus 3. Now I apply the zero products property. If x minus 4 is one of the possible values of 0, then that would equal 0. This is the other possible value of 0. And now I solve. If x minus 4 is 0, I add 4 to both sides. If 2x plus 3 is equal to 0, then I subtract 3, and I get 2x equals negative 3. And then since it's being multiplied by 2, I'm going to undo that by doing the opposite. So I get x is negative 3 halves. Crazier looking response. But again, if I were to plug that in, I would end up with the right solution, that 2x squared minus 5x minus 12 would equal 0. Okay, hope that helps for factoring quadratics.